I think it means we're live. Oh, live in 7, 8, 9. We are live, folks. So welcome. I know it's a little early. The entrance tickets are out. So get to it. Take a special note on what color suspenders Mr. Blunt is wearing at this time. I'm looking right now. We do not have a translator yet. She may not be able to make it. Zane, hi. Chloe, hi. Cynthia, hi. Mr. Bartlett, hello. Tula, yeah. I better put on my glasses. Gracie Thompson, oh, that's August. Parker, yeah. Oh, you guys. Mario, when is the entry? It's unlocked now. You guys go to it right now. Do it early. I will probably give you points for doing it early. Likely. Remind me. All right, folks. Again, we're a good 7 minutes early, so we're not in a hurry. I got my favorite beverage, Coca-Cola. I'm going to try and do everything myself. I don't know if I can. I will probably make a mess of things. Anyway, I got all this going on. Billy, Dan, yeah, Paige. I do know how to monitor this. So if I see some cussing, oh, August, whoa. Yep. Kenneth, yep, nice. Paige, Noah, use sexy. Oh, is that someone I have to 3-button? Put user in timeout. Hide user on this. Remove report. Oh, I don't know. Use sexy. Novus, Noah. Oh, all right. Clark, when I see you, I'm going to make you a moderator, so come on in. Yeah. Sorry if I keep looking down over here. That's where the other computer is. Maybe I can kind of work this out. We do have a great night tonight. You guys, we have an amazing night. I've actually got a color version and worked on it yesterday, last night, and it was amazing. And why did I lose everything? Okay, so I'm still looking. It's not unblocked, though. Oh, is it? Brett, I owe you a point. Keep an eye on points. I didn't know it wasn't unblocked. Let's go responses. You're right. Jeez. Kenneth, I owe you 2 points. Remind me back in class. All right, it is unblocked. I don't know why that does that. I really don't know why, but it is now accepting responses. Good. Entrance ticket, check. Yep. Paul, it's available now. Entry ticket not accepting. It is. It's working. Hi. Emma, hi. Entrance ticket. Yeah, you guys. Caroline. Yeah. Keen. Yeah. Okay. It's open. I've got 5 responses. 6 response. I'm getting the responses. Okay, you guys. First one's going to get an extra point. Let's see. I should check those now. I know you like saying, Mr. Bartlett. No way. Yeah, way. Give you extra point for being first one to check in. And that was Matthew Grimes. You are first for 4th period. You get a point. Matt Worley, you're first for second period. You get a point. Emma, you're first for 5th period. You get a point. Dachi, you are second. No. Mario, first for 6th period. Get a point. Brett, first for 1st period. All right, all you guys have got points. Everybody else, oh, I'm waiting for 3rd. Chloe Walker, you got first for 3rd period. It took a while. Okay, so you guys get those in before 6:45. All right. There will be time for me to look over at the chats. But in between, suspenders, Nina, I need you. But I know you have a birthday to celebrate. We can almost do this with Zoom. I can make you a moderator. Hey, if you could be my moderator, let me know, son. That would be Sunkissed and Freckled. That's Nina. I would have been cool to see a snowman next to the telescope. I got a quick view. Yeah, he melted. The boss made it and melted it. Totally Kenny. I would have been, okay. Attaboy, Matt. All right, Karen, I love your positivity. You guys, I'm loving you guys. Okay. Still not time for the official start, so I do want to go over some things. Did you make a copy of your constellation sheet? Because you're going to be annotating that tonight. And really, I really think you're going to see things that that is just, to me, beautiful. And if you realize what you're seeing through the telescope I've got, it's pretty amazing. So again, I'm wasting time. Let's keep looking at this. Super Mr. B, John Cross, love your positivity. No points yet. All right. Keeping it up. Now, you guys are, I'm using OBS, okay, which is a gamer thing, so I might make some mistakes. Clark and is Clark here? I'm looking for Clark. Clark Otron is, okay, Clark, you know what your job is. You are a moderator. August, I can't let you be. That's not your job. You have another job. All right. Clark Otron, you are a moderator. Get rid of the bad people. You're not here to answer questions. If I had Sunkiss and Freckles here, my daughter, she would be able to read all these things. So you guys are going to have to be patient because I feel like I'm this one-man circus. All right, 2 more minutes. All right, I'm going to get at it. You are doing your night lab. I've got 2 mice going on. I got 2 computers plus telescopes. I'm not complaining. 80 people responded. 81, get those in before 6:45. Then it'll close you out. It will close you out. So be careful with that. And then you'll have to come to class. All right, great way to spend class. I know Saturday night you got better things to do, but if you don't, one thing better would be being out with your teams, working and finding the stuff yourself. But in this case, the equipment that we've got here, the location, it is a pristinely crystal clear night, steady seeing. Last night was amazing. To give you a taste of last night, I made one, without any copies, I made one image, which I'm going to make more. You're going to screenshot and check this image out. This is from SharpCap. I swear to you, I did nothing with this. I just printed it. Yeah. Actual size. This is the Horsehead Nebula. You're going to see this tonight. The colors. This is real. And I'll go over how this is done. But pretty amazing. Clark, I'm here. Yeah, Clark, I made you. What? You're the moderator. Clark was going to go mad with power, Miss Mario. Yeah, Mario, I figured that would do it. I have a mediocre 15-gram look like metal and dark black. Sadie, I don't know what that is. You know it. Okay, you guys know better than I am. All right. So I just showed you this picture. I just thought it was amazing. Expect not of them to be like that, but you will see this in color. That's amazing. All right. It is time. It is 6:30. I've got a few notes, which I'll be reading. But first, I want to let you know what you're doing. Okay, you are going to explore into the reaches of our home, our galaxy. Oh, Mr. Bartlett. Yeah, we are actually in the Orion Arm or the Spur. Let's take a quick peek what I'm talking about. Yeah. So here's I don't know, first artist impression, JPL NASA. Here's the center of our galaxy. It is Bard Sparkle. Here's our solar system. See that plus? We are between these major arms called the Perseus Arm, which starts about 7,000 light years away. And we're really also on this edge of the Carina Sagittarius Arm, major arm. We are on the Orion Spur. I know it says Orion Cygnus, but we're in it. But because of the fact that we're in it, we're also in this bubble called the local bubble of about 300 light years across, where there's 1/10 the gases that normally are in our galaxy. So we're in this hollow area. Maybe a supernova cleared it out for us. But even though we're in this arm, we're in the bubble near the arm. So we're going to see a lot of great stuff at Orion. All right, I'm taking a break. 6 suspenders, Dan. Billy. Oh, I love the respect. Clark is going mad. I already seen this. Ishi. Oh, Aunt Anthony. I like pancakes. I love pancakes. Nick, give you a point. Remember that. Remember all points tonight. We'll be taking care of all administrative purposes. But yeah, you remember your points. You come back to me in class and I'll give those to you. You got to remember them. Send pick, contact, email, and other links. Did it start at 6:30 or earlier? Yeah, officially 6:30, but you have till 6:45 to, get your entrance ticket taken care of. But more importantly, yeah, I like starting early. Why? Because we could talk. All right, so we are in this bubble. And because of this bubble, we are near this busyness of our arm. Now remember, we're looking face down at a galaxy, and now we're looking sideways into it. Okay, that's cool. I like it. Entrance ticket away. Whoa, I missed that. Sorry about that. Uh-oh. Oh. Hey, I'll just push that. Sorry. Little uh-oh, I hate the uh-ohs. Okay. So, we've got some excitement even though we're where we're going to start where we left off in the fall sky survey, but I want to let you know what's going on. Okay, we got new stuff. You might see the telescope, bottom screen. Here it is. This is live. You'll see it changed. I know it's black and white, but remember, it's an infrared camera, and we get to take a peek and look at, black and whites, although I could show you color in a minute. We are now using a different program to capture images. This is it. This is the color program. More on that later. Right now, it's capturing the Heart Nebula, so we're going to have a bunch of things stacked on each other. And then this is what you really need, the constellation and the location where you have to annotate the objects we see. And you're going to have to write small. Okay, so before we get into the chores, let me get this, still notes. You got an exit ticket to leave with. You're doing your winter constellations. You're taking screenshots and notes. So you guys, you got a lot to do. All right. And in between, while we're stacking images, I'm going to come over to the live chat and see what you guys are missing. I do love pancakes. Kenneth, you're late on that. Want to hear a joke? No, John, don't want to hear a joke. and Clark, I'm depending on you. I'm worried about those jokes. Okay. Let's take a quick peek at the scope and setup. I'll talk you through it. I promise you won't be long. I'm going to come back over. You might have seen this before. I'll pop the screen, and I took a little video, so stay with me. Oops. And if you can hear it, let me know, because there's sound. No, there is no sound. Okay, so the scope works by two things. I can control it up here in the room, or I can control it by the hand controller. And what I did last 2 nights is I had the scope memorize the sky, take pictures, so it knows where it's at. Now, a little bit of optics. Here is one mirror in the back. That red thing's the camera, and light goes in, hits a concave mirror, and it causes the light to converge on that camera. Now, the camera is a cold camera. It gets rid of some noise. I got to get rid of the dew. I got a dew strap over here. It is called a RASA, Roe Ackerman Schmidt Ashgraf. Yep, that was easy for me to say. And this thing is 11-inch in diameter on a really decent mount. This has got a crease in the telescope, and you don't need to see any more of that. Okay, that's the scope we're using. Nice. We'll get that back down. And once again, the scope is viewed on this screen. When you see it and we're looking, there it is right now, pointing the right spot in the sky, or I could even go directly here to take a peek at it. Nice. That's the first thing I want you to know. Great. So, that's how it works. We're at 7,700 feet, dry, clear, pristine air, Bortle skies better than 3, so like 2 something. And how I'm going to go with this image, which is a new program called SharpCap, and this will take the images as it is right now. It's taken 14 images or 3 minutes, 30 seconds, and you look at that and you go, there's nothing there. We'll see in a moment. This will be our first object. All right, so what will happen here is this will stack the images. I love it. And when it's stacking, I can talk and look. Right now, Henry's saying, hi, Mr. Bartlett. Will you go over the notes at the end of the live session? Yeah, probably at the end. I'll try. Christian, great question. John Senna, a summary. You're scaring me. You're not the real John. You are John Cross. Yeah, so I will get to the chats, but I want to make sure we're off and running because we are taking a survey of the night sky. We're not looking at stars. That's your job back in class. What are you doing in class? Winter star survey, where you're collecting all the physical properties of all the stars in your constellation. This is the good stuff. This is the beauty. This is the junk, the debris, the gas, the dust, the lighting, the clusters. This is the stuff you can see fairly easily in dark skies. Okay, here we go. We're starting with the first thing. You need to record where we're going. We go here first. The first thing on the list is actually underneath Cassiopeia. And you might notice the yellow bullseye is where it's at. The red bullseye is where it's going to be. Oh, so what you're going to right now do on your chart, take your chart and find the location. Now, I'm not going to repeat anything more than like once, maybe twice, but you are going to go to SkyX where I'm at. You take a look at the bullseye. It's right below Cassiopeia, right above Perseus, and right down, in this case, you're making a little weird oblong shape. Let me get closer so you can see. Like a pork chop. Whoa, that would be the wrong way. So we're looking at the Heart Nebula. So there's the box that the telescope's looking at, and you kind of make a weird pork chop in the sky. What kind of pork chop? Well, it doesn't matter. Okay, now we are pointed there. Remember, we were all up in Cassiopeia. We saw the Bubble Nebula, all that other cool stuff. But we're at the Heart Nebula. Now let's go see it. Oh, remember, you're going to see this twice. You record it, put a bullseye. This is a what? This is a reflection nebula, RN. So you just put a little outline. All right, good. And I'm going to get to you guys. Don't worry, I will be there. Sharp cap. Now, this is what I got to play with. This is the image that it's been stacking, and you'll get a feel for it in a moment. All right, so there it is. Let me play with it. I've got to stretch the image because we're seeing only the faintest stuff. First of all, I'm going to take the blacks. I'm going to bring it up to about here. And then, oh, there we go. I'm now going to bring the middle colors, and hopefully the images will show up. And there they are. Oh. I'm going to make it a little darker. Oh, yeah. And a little brighter. This is the full stream. We are inside the Heart Nebula. You might see the outline here. My cameras and telescope setup doesn't have a wide enough field. It's a big heart in the sky with the middle here. All right, this is where you take your screenshot. And this is where I get you information that you write down. Screenshot this. All right, what do you write down? The Heart Nebula. Magnitude 6.5. I'll get to you in a moment, guys. I know people have questions. August Thompson, science. Magnitude 6.5. So it's barely just beyond our natural vision. Size. This whole thing is 1 degree by 1 degree. You don't write down sizes. I like sizes, so I care. We could put 2 moons in here because it's 1 degree by 1 degree. Distance. About 6.5 to 7.5 kilolight years. That's 6,500 light years away, and it's in the Perseus arm, that other arm. Look at that nice little cluster here. So this is the Heart Nebula in Perseus. All right, take your pictures. I'm going to too. I'm going to save an image. There I go. Snapshot in progress, and I saved it. Oh, yeah. All right. I'm now going to go to the Sol Nebula, and I'm going to do that, and then I'm going to take a break as it stacks up. But look at the colors. I can make it even better. Oh, baby. Look at the colors. Oh, remember what this is a emission nebula, not a reflection nebula, emission. I take that back. It is a bunch of glowing clouds of gas making new stars. And you can see the upside down heart. Okay. Glad we were there. That's beautiful. Come on, that's beautiful. All right. We're now going to the soul, the heart and soul nebula. So what I'm going to do, this will take a moment. I'm going to type this in over here. Soul nebula. I'm a soul nebula. I'll click soul. I'll say find. I'll back it up so you guys can mark it on your chart. Another emission nebula, EN. Notice, here's where you mark the top of Perseus, the heart nebula, and the soul is right next to it. All right, so you're marking it down. I am going to clear everything. Oh my gosh, you guys, I'm so sorry. It's just so much to do. All right, I got to clear this. Clear, paste, pause, clear, resume. Okay, you guys are marking stuff down, and I'm doing my thing. Okay, we are now doing the Soul Nebula. Okay, good. Let's check that out in a moment. All right, now I'm going to come over here as this thing loads up. I'm going to get you over to the big screen. The telescope didn't move much. Here it is. This is the Soul Nebula loading up. I'm going to let it do it. I'm going to change some of the parameters so we can see it again. I'm bringing the darks. Well, my gosh. Did it move? It's the exact same thing. We didn't move. No wonder. So bad news. Mr. Bartlett screwed up. I got to go back. God, you guys, once we get going, we'll be good. All right, back to here. I never moved it. I got to move it. So watch, slew. And it goes over to the Soul Nebula. There we go. All right, you guys, I'll be with you. Right now, once I get this, I got moments to break. Now I'm going to come back here. I want to clear this mess. And make sure you guys could see the image now, right? So let me get that to it. Sharp cap. Here we go. We are now taking 15-second exposures, adding themselves to each other. And it is now gone. Okay. What am I missing? Can you repeat where this is? John, no, I showed you. Oh, the constellation? Really, Cassiopeia? Yo, teacher, is her paper upside down? No, the telescope is. I can't control that. You just have to turn your paper upside down. Shut up, Jumbo. Oh, John. Hey, careful, Clark. We might have to get rid of the Senate guy. Let's be nice in the chat, please. Dan Bartlett. I love you, Dan Bartlett. Whoever you are needs to be another moderator for extra points. Not even the real John. Jim's got the right idea. Abigail. King Bartlett. Abby. Geez, you should know all of this. You know. I wish your father was here helping out. Oh, we got some weird stuff going on here. All right, I'm adjusting while we're talking. We got the Soul Nebula coming up here. The Soul Nebula. Oh no, BARKL. What are you guys doing? Is there a table in how to list the objects? I'll keep going over them. Everyone settle down. No, there is no real Dan Bartlett. I do not care. All right, that's enough. We need to remove the aliens in the chat. Who are you? Okay, not funny. All right, well, I'm glad I wasn't paying attention there. All right, it's a little green on the background. There we go. We are getting the Soul Nebula. What do you need to know about this? Well, we know the Heart Nebula. The Soul Nebula is the same location. Its brightness again is 6.5. Its size again it's one and the same. It's 1 degree by 1 degree. And again, it's 6.5 or 7.5 kilometers in the Perseus arm. They're the same clouds. Now I'm going to make it a little bit brighter so we can see it. And you don't see that heart shape anymore. You're seeing, I'm going to I'm bringing this over. It almost looks like the same thing, but it isn't. So we've got this weird thing going on We are in the solar area. Take your snapshot. Remember where we're recording? They're right next to each other. We got star birthing region. Kind of pretty. Got some glary going on. All right, good. Moving on. Clark, good. Whoever the real Dan Bartlett is, I don't know. Okay, we are now going to another double thing. So these were double emission nebula. They were both the same distance and everything else, so you can report them. They're both emission, and they both are birthing stars. You can see them. Next, we're going to see what happens when stars have been birthed. All right, we're clearing. I should have taken a picture of that, but I didn't. All right, next thing to do. We're going to something called the double cluster in Perseus. There it is, double cluster. I'm going to find it. Notice where we're at. Yes, turn your paper upside down. We're looking northward. So if you got it, you on your constellation sheet, go ahead and draw it. It's to the, if you turn your paper upside down, it's to the left of the hat. And this is pretty amazing. I'm slewing now, so goodbye to the heart and soul. We're slewing. The telescope in the bottom of the picture slowly moves a little bit. All right. Now oh, you didn't see, did you? All right, back to, God, that was terrible. All right. Yep, same distance. Do we screenshot this? Yes, you screenshot the soul. If you don't, you're a mess. All right. So again, this is where we were. We were at the soul. This is the red where we were, and now we're at the double cluster in Perseus. All right, so get that, draw that on your map because I forgot to show it to you. We're now going to the double cluster. The double cluster are two open clusters that are fairly young. They're only like 5 to 7, 3 to 6 million years old. That's it. So we're now there. Let's go back and capture the pictures. All right, we're going back to sharp cap. Good. I'm going to sharp cap away. I'm going to clear this mess, and then I can look at your chats. Now I'm resuming. And after 15 seconds, the first images will appear. 15 seconds. All right. I'm looking. Do we need screenshot? Oh, yeah, we always do. Yes, John. Thank you, Paul. Paul, get a point. Where's the map, Mr. Bartlett? That was old. We fixed it. All right. Can you clarify the double cluster, please? Yeah, I'm going to give you all that. Right now, we're collecting 15-second images, and they should pop up any second now. Now, at first, they're just stars. What are they? These are the two open clusters. They're called the double clusters H and Chi, or NGC 869 and NGC 884. Just put down the double cluster. Now, one thing I forgot to do is make sure we're aligning frames. We are. Okay, good. Okay, now, what do we know about these? Magnitude 5.3. Easy to see with your naked eye. Beautiful in binoculars. These are two clusters kind of far away. Distance 6.8 light years. Again, in the Perseus arm. All right, let's get them better. Don't take the screenshot yet. Wait until it adds up. All right. Bringing out the colors. See if there's any details. Oh, look at that. Again, I'm bringing out the colors. Size of these, about half the size of the full moon each. So the full moon would fit there. Mario, I already did the map. Not going to do it again, but you'll see it in a minute. Yes, can't we see where the double clusters, though? We'll show you in a moment. What's the number label for the double cluster? Put down the double cluster. Or you could put down NGC 869 and NGC 884. Your choice on that. Distance, 6.8 kilolight years. That's 1,000 light years, and it's gorgeous. These things are young. They've been seen since antiquity. Hipparchus, the guy who developed magnitudes and other things, 130 BC, he listed them. Both are young. I told you that. 3 to 6, one's 3 and the other one's 6 million years old. They're blue shifted. What does that mean? If they're blue shifted, they're coming towards us, and they're coming towards us at 22 kilometers per second. So they're in another arm coming towards us. A little bit reddish background. I don't know why. A little green there. But this is not even a full size. You want to see full size? 100%. There's 100% size. Look at those. Beautiful things. All right. Nobody about? Okay. Mo Lester. All right. Clark, get rid of Mo Lester. Get rid of him. Just gone. What do we label it on our notes? Double cluster. Amelia, just double cluster. Auto scale. Take your screenshots. I'm going to do the same. There it goes. I'm going to screenshot that. Jimbo Miola. All right, fine. So we're going to move on. There are 2 open clusters. Oh, I forgot to tell you. Let's go take a peek at this. All of these objects, the ones that we've seen, both the heart and soul and the double cluster, are in the arm, right down the arm. And I gave you numbers, 5.3 magnitude, 18 minutes, you don't need that, at distance, 6.8 kilolight years, and the arm. So you need all that. Okay, next thing we're going to, and there's where they're located. The heart, the Soul Nebula, right next to the heart, and the double clusters right there. Next we're going to is M34. Let's search for it, find it. Down in Perseus. Down we go. All right, away we go. Slew. Now we're getting together. We're going to start picking up the pace. Okay, so we're there. That's where you annotate on your chart. Write down M34, and it's an open cluster, OC. Yeah, no, Amelia, the double clusters are stars, open clusters. Yep, Molester's hidden by Clarkotron. Nice, Clark, you are doing your job. Copy and paste link. Okay, let's go next. Sharp cap, let's take pictures of this. Yeah. And then I can look at some things, ask some questions. I know there's a lag here. All right, I'm going to clear. I'm going to pause, clear, and we're going to resume. All right, this is M34. All right. M34, what is it? We're starting a live stack. Here's the information you need. It's an open cluster. Remember, there's globular clusters. Last time, the open clusters are a gaggle of weird shapes and sizes, tens of thousands of them. Yet, there's only several hundred of the globular clusters. All right, M34 magnitude 5.19 or 5.2. That's visible to the naked eye. Binoculars, easy. I've seen them both. Size, 35 minutes. You don't need that. That's the size of the full moon. I need to adjust this. I don't like it. Darken it up. Here we go. We had a trail right there too. All right. I'm bringing up some colors, some brightnesses. What else do you need? Distance, 1,600 light years, 1.6. So this one is in our arm. It's close by. It's near Agol, about 80 to 100 stars, open cluster. The other ones were 3 to 6 million years old. This one is 200 to 250 million years old. And it's got the same motion as the Pleiades in Murphec cluster, and they're going together. Really cool. As it adds up, you take your screenshot. I'm going to read. Where are we? What is this size like in degrees? Sid, you don't need sizes on this. I do this because I like it. Copy and paste. No, he isn't. Jim, who's this Jimbo guy? I don't know. What's the magnitude? Again, for this one, the magnitude for M34 is 5.2. Define mag, please. visual magnitude is how we see it. If it's fifth magnitude, we're on the verge of not seeing it. The smaller the number, the brighter it is. So our brightest objects, the sun is negative 27. The moon could be about negative 12 almost. Venus, the brightest other object, is about negative 4.4. The brightest star is about, the Sirius is negative 1.3. So those negative numbers are the brighter ones. This one is barely visible to the naked eye. They said we can see about 5.5. All right, guys, there's time and a place for jokes. Dan Barlow, I'm not doing that, you guys. You'll know when I do it because I have a yellow tag. Watch, I'll say something. I'm real. I'm a real boy. There we go. I'm that. Okay. Yes. So take your screenshots. I'm going to take my picture. That's M34, open cluster. And we're going to go to one weird thing in Perseus, and then we're going to leave and get into triangulum real quick. Okay. Take your screenshots. You got it? Good. Clear. I'm going back here. Where are we going next? Well, in here, we're going to something called the California Nebula, dude. California. All right. And this is one I've always tried to see before. Oops. Find it. There it is. Oh, it may not get to it. So you guys, lower leg, turn your sheets upside down. And it is a emission nebula. I know you've been putting DN, but put EN instead. Emission nebula. It is a very large object. Let's close in on it and show you what it looks like. I don't know if I can get to it. I'll do my best. You might see it. It's like a long gaping wound in its leg. All right. And yes, M34, Mario point. M34 is in the arm. California Nebula is in the arm. In fact, nope, it's in the arm. Is it near the leg? No, Natalie, it's in the arm, meaning the spiral arm of the galaxy, not the arm of Perseus. All right, let's go and capture some nebula. Sharp cap. Ooh, it's a mess right now. All right, I got to clear this. All right, now we're resuming. All right, so this is the California Nebula. I don't expect much. Yeah, I'm real. What's the size of M34? You don't need it, but it's the size of the full moon, 35 minutes of arc. All right, we're not seeing anything, but it's only pictured one. Oh, because I forgot to put resume. All right, and that doesn't look, oh, did I do it again? Pause, clear, I do that all the time. We need to slew on over to it to get it. I hope it doesn't crash. We're going to do our best. It might crash. All right, so just sit tight. I moved it over. I don't know. I'm pushing the limits on the scope. I'm going to clear this again because we're seeing M34 again. All right. Pause. I'm going to read some notes. It's near the leg. Okay. We got it. 3 miles long. Who's Jimbo Lope? Size was 35 minutes of arc. Very good. Lydia, thank you. Told you, Natalie. Thanks. All right. Come on. Capture some. This is an emission nebula, the California Nebula. It's got a lot of stuff going on. Visible magnitude is 5.0. Uh-oh. That's the first image. Don't see anything yet. Size is 2.5 degrees, but you don't need it. We're looking at 5 moon distances across. We don't see anything yet. And it's only 1,800 light years away. So it's about the same distance as M34, which is 1,600 light years away. All right. I'm going to bring up the darks, make it darker. I'm hoping we get something. And hopefully we'll see California come out of this. Oh. I'm working on it. I'm working on it. That's not bad. Again, we should see some cool stuff tonight. Interesting. So as it stacks multiple exposures, it gets rid of the noise and brings out more of the fainter detail. That's not bad. Remember, the whole length of this, wow, it's huge, is 5 moons across. Take your snapshots. I'm going to give you the data again because I can, and then I'll look over at the chats because I got time. California, I can only see it in photos only, even though it's 5.0 magnitude, distance 1,800 light years. It is an emission nebula. The gases are being excited. Guess what? This thing is in the arm of, it's in our arm, outer part of our Orion arm, in fact. So the entire region has many, many masses of stars it can form. So this thing is forming. So we get all this gas and dust. Red because it's hydrogen emission. It's the alpha hydrogen line that you did in chemistry. All right. What's the difference between planetary and diffuse nebula? Parker, it's a great question. Planetary are the end product of stars. We'll see 1 or 2 tonight, but the diffuse nebula are broken into 3 types. And I'm giving you a point for this. In fact, 2 points. So diffuse nebula are emission nebula, the red stuff. Take your pictures, guys. They're the reflection nebula, which we haven't seen yet, and then they're dark nebula, the gas. So we got 3 different types, but a planetary nebula is a exploded star, but maybe not total explosion. All right, take your pictures. I'm going to do it. Boom. I'm waiting for it to take my next exposure. You guys capture your stuff. It's gorgeous. And now we're going to do something completely different. We're going to do something we did last time. We're going to leave Perseus. I'm going to reset this. Goodbye. I'm going to clear it. I'm going to pause. And we're going over to M33 again because it's nearby. So let's go over here. So I'm going to type in M33. I'm going to find it. We're going over near the house. So up near triangle, notice everything's upside down. Let's see if I can make it better for you. There you go. All right. Yes. Now we're looking south. We're going to M33. Draw it on your constellation chart. And I'm reading. I love it. Jimbo. 1,800 lighters at 5.0. Oh, good language. Give you a point. I don't know who you are, but tell me that later. In the arm, okay, we're leaving the arm. We're going into the face, slewing to it. Goodbye, California Nebula. Just going back over. Come on. Moving over. Look at the scope. It's moving all the way over there. I'm reading. Paul, you're giving me mixed signals here, Jimbo. What do you mean we can't see? Don't tell me I did it again. Who said we can't see? Abby, point. I messed up. Here's where we are supposed to be. All right, keep looking. We are now in the face, M33, galaxy. We'll check this out in a moment. In a moment. All right, so keep looking. Record. M33, let's go on over. I'm such a spaz. Shouldn't have old people do this. All right, we're going back to SharpCap to look at the image. This is a galaxy only because we've done it before, but it's like my favorite galaxy. All right, we can't see. Yeah, we got you. We got leaving the arm going to the head. All right, you got it. Okay, now you're in SharpCap. Good. Thank you. Now I'm going to bring up some colors. First of all, let's bring up the dark lines. Bring it up so I can bring them darker. Then I'm going to take the mid lights. I'm bringing them down. Oh, look at that baby. Oh, look at that baby. That's a weird color, I know. So here's M33, 2.9 light years away. No, 2.9 million light years away. The furthest object, a little red if you ask me, the furthest object humans can see. Now a little green. God, sensitive, isn't it? Maybe if I do this. No, it wants red. Too green. All right, so give you some numbers. It's in triangulum. 5.8 is the magnitude. Almost as faint. I have seen it in New England, and it's a little red. I really don't know why that is. What if I bring up the green a little bit? Oh, hell no. I can't get rid of the red, guys, but I can darken the background a little bit. Look at that galaxy. Face on. And what else do you need to know? Size? Well, shoot, it's only about up and down one moon. You could put a moon there, and in between you could put two from the long axis. It's near M31. Gorgeous galaxy. I just had to do that. I know we saw it last time, but we didn't see it in color. Bro, that ain't no red. Jimbamilla. All right, I know. I can't seem to fix the red. Then it gets too green, right? What if I turn down the green? Oh my gosh. Hold on. Now it's purple. All right, I'm trying to match the RGB colors. You can see that they're not matched. They're not matched really good. That's me more than anything else. But you can see all these colors. It's got a touch of orange. But hey, look what you're looking at. 2.5 million light years away. It is in the local group. Make sure you put that down. Magnitude 5.8. Yeah, you guys got it. You're getting this down. All right. I had to go to a galaxy. It is a local group. I didn't want to go. We could go to the Andromeda Galaxy, but we got more to see. That was in the fall, but we didn't see it in color. I'm just trying to bring this out. Take your screenshot. M33, the Great Triangular Nebula. Hey, let's get close a little bit. Notice you got some emission nebula. Oh, you're starting to learn. Look at the emission nebula right here. Look at the mission nebula here. Look at all the hot pixels, the reds and blues. They're everywhere. No, too small. Okay, I'm not impressed, but I'm going to take my snapshot. It's taking my picture. It's waiting, and then we're going to go on, and we're going to Taurus. Let's go for the Pleiades. Seven Sisters, Subaru. God, my favorite. Well, whose is it? All right, let's see. Pay attention, Katrina. Is this an open cluster? No, Paige. It's a galaxy. It's a Type SC galaxy, wide arms, flat face. It's 2.5 million light years away. Oh my gosh, I love it. Okay, I took the picture. I'm going to cancel, clear, pause. All right, now I got to remember to have you guys go. We're going to go back. We're going to go to Pegasus. Yes. Look where the telescope's now pointing, right over the house. That's the problem. I have a security camera that has all that infrared pouring off of it. So that's what's going on there. Okay, where are we going? Pleiades. Type in M45. And I will say find. There it is. How can you miss this? This is one of the most exciting clusters. Actually, the face of Taurus is too. All right. You guys draw it in. M45 OC, open cluster. I'm slewing there now. Watch the telescope move. Very, very little by little, just after the meridian. All right, what are we getting? And you know what? I think we'll take a break in a little bit. After we get, I think when we get done Gemini, everything picks up, so we'll take a small break. I got a Coke to drink. All right, and let's go back to SharpCap and take some pictures. All right, and then I'll answer some questions. All right, the Pleiades. Let's see what it looks like. Resume capture. Blow these away. Clear these. All right, we are capturing 15-second images on top of each other. Here it goes, the Seven Sisters. Auto adjust the colors. All right, everything's a little backwards, and I'm not quite framed here. Hold on. We're going to pause this for a moment. I'll get back to you guys. I'm going to pause this. Clear it. I'm going to pause again. I'm going to use another controller. I want to get M45. I'm going to tell the telescope to do it, not the program. So menu menu M45, enter slew. It's going to center it better, I think. It is done it. Don't worry about changing where your location. It just did a better job. Now I'm going to resume, and we will Again, okay, clear that. Yeah, it's going to do a better job. All right, open cluster. What do you need to know about the Subaru M45? The Pleiades, magnitude 1.5. Almost everybody who's ever looked at the sky has noticed them. A lot of people think it's the Little Dipper. Oh, I don't know if it's any better. Wait till we see it. 2 degrees wide, so I can put 4 moons here. And again, it's reversed funny. 450 light years away, close by. Now, bring it up. Mr. Barlow, what's your favorite ice cream color? Color? A flavor. Do I have to have one? I don't know. All right, let's turn these down. I don't know. Someone works at an ice cream place? Check this out. I'm going to bring it up. Oh, you're seeing it, aren't you? You're seeing it, aren't you? Oh, this is incredible. What is going on? You need some numbers. Let's let it stack up. I want to darken it a little bit. Oh my God, this is beautiful. Okay, a little too much darken. Okay, we're stacking images. Do you see it? You got a reflection nebula in front of it. So here's what we got. You need the numbers again. Magnitude 1.5, size 2.0, distance 450 light years. It is close. All right. 7 sisters, known forever. The Japanese made their logo after it. They were called different names. Almost everyone has noticed it. A lot of people confuse it for the Dipper. Now remember, my image is backwards because the telescope is. The nebulosity you see in here, look at it, it's adding up. Let's get more of it. I'm going to take this down a little bit. Take this up a little bit. Nope. I'm going to see how much nebula we could see. I know that's a little gross. Oh, look at that orange star right there. I know your screen may be different than mine. Let's make it brighter. Holy schmackaroos. You guys, you don't see it like this, only in pictures. I'm not taking pictures. This is right out of the telescope. I know it's stacking different pictures together, but that is just gorgeous. What else do we know about it? The core is 8 light years. There's really 1,000 known members. 1,000 stars here. Tidally, the whole thing is about 43 light years in diameter. Remember, our closest star is 4 light years away. Sirius is 8.6, 8.7 light years away. This thing is 43 light years across. The reflection nebula really isn't associated with it. And you might go, what? All right, what about it? Yeah, thanks, John. I meant arm. Oh, good question on this. Again, arm. We're in the arm. Good question. I forgot about that. Remember, we were in the local group for M33. Keep reminding me, guys. I forget it. And I don't have a favorite ice cream. Okay, so look at this. You can see the orangey background and some of the light pollution that I got. And maybe I could touch this down. God, what? I wish it was a little bit easier for me to touch the background. Now it's too green. What if I click on this? It turns red again. All right, take your snapshots. Agreed. It's not that gorgeously blue. If I bring this way up, it looks more like it. Not as red. I'm going to go in an in-between color. The nebula is going at a different speed than the stars. The stars are going right through it, but these clouds, this reflection nebula, and this is an open cluster. It's an open cluster, hodgepodge. I'll take my image. So we're taking our image. You got yours. I want to get mine because I just think these are neat. All right. Next. Yep. 450 light years away. Next, a treat. We are going to see a supernova remnant. All right. Clear. Okay. Where are we going? Take the scope. We're going to go to M1. Watch the scope move in all its glory. I'm going to take Sky X, and I'm going to type in, wrong one. And I'm going to type in Messier 1, the Crab Nebula. Here it goes. Find it. It's on the other side of the meridian, so watch the scope. Okay. I'm slewing. The Crab Nebula. was named for the first guy who took pictures of it. In 1054, the Chinese recorded a star. Look at that telescope move. A star that was brighter than Venus, -6. It shined in broad daylight for 23 days. This is where we're at. Whoa. Okay, record that. All right. And for almost 653 days, they could follow it. All right, let's go find this thing. The star totally obliterated itself. It has much energy as the entire galaxy. All right, I'm going to read some of your stuff as I get this thing loaded up. And they named it the Crab Nebula because that's what it looked like. So people are talking about fun. Funny, does M1 mean it was the first Messier object recorded? Sophia, 1 point. Yes, it's the first one he listed, Charles Messier. Sounds like I'm about to get molested by Paul. Jim Bolina, careful. You're okay. It means it is the biggest? No. All right. This is a supernova remnant. We've seen it expand. Magnitude 8.4. All right. Are you guys in the right spot? I'm not. Let's bring out some details. Everything we've been talking about. Okay, that's the dark end. Here's the mid end. Everything a little green. Let's see if I can fix that. Oh yeah, this is intense. All right, so this is everything else we've been talking about. Size of the full moon. This is only 4 minutes by 8 minutes of arc. This is the same scale. We'll get into full scale. Distance 6.2 thousand light years away. Let's see it a little closer. That's wicked. Imagine a star totally obliterating itself. But it wasn't that big of a star. You know what's left of it? A neutron star, a pulsar that pulsates 30.2 times every second. It's in the middle, and it just flips. It gives us radio bursts. That's insane. Was called Crab Nebula by Lord Ross due to his drawings. You know, it's just pretty crazy. Let me bring it into darkness a little bit. A little bit lighter. And I think when I do this, I lose the color of the background. That's a little too much, too intense. So there it is. There's a star that blew up at 1054. All right, I'm going to read while you guys are, I don't know what that means. What do we got? Oh, that was something else going on. All right. What do we got for questions? What type of object? It's a planetary nebula, Harrison Point. Harry, you got a point for that? It is a planetary nebula, 8.4 magnitude, size you don't care about, but it's 4 to 6 minutes. The other ones were like, remember, the full moon is 30 minutes. Distance, 6.2 thousand light years away. Magnitude, we did that. I hope you didn't lie about the magnitude, Joe. Is this the arm? This is still the arm. We're in the arm the whole night. Our own Orion arm. Pretty crazy. Okay. A word about distances. I'm going to take my picture here. I'm going to bring it back because, you know what? It's good to get the scale. I think it's a little... That's what's left of a star that completely loses its life. All right. Screen capture, planetary nebula. You could say supernova remnant because that's what it is. I'm trying to get the right color. It's kind of neat. Definitely kind of neat. Okay, let's go ahead, take my picture. Taking my capture. It's waiting for it to get done. There's a little brown on this. All right, folks. You guys are hanging in there? Good. Taurus, we're done. But we do want to take a look really quick at the Hyades, just to look at it. Don't take a picture of it. Get back to here. Look where the scope is looking straight up. Wow. And if I look myself over here, you can see the Hyades, which is right here. So here's an idea of distance. Here, the Hyades is about 300 to 400 stars, 150 light years away. That's 150 light years away, an open cluster. You don't have to do it. The Pleiades is 450 light years away. All in the arm. We're all in the arm of our spiral arm, the Orion arm. And then this is, this is 6,000 light years away. Crazy. Okay, we're going to scoot on over to Gemini. We got a treat here, but the best stuff of the night is still yet to go. When we get in here, breathtaking. When we get in Orion, even more breathtaking. All right, next one. Label it M35 open cluster. Find it. The bottom end of Castor. And we know the story with Castor. Castor was the mortal one. And Pollux was the immortal one. Twins, same mom, different dads. Figure that out. All right, you're recording it. Let's slew on over. The scope is going to move a little bit. And I love this one. I really think this has got a neat thing going on to it. Okay, I got to clear. And I'm going to let it go. Give me a second. I'll get you guys on. All right, you drew your picture. That's where it's located. Back to Sharp Cap. And after Gemini, I think we'll take like a 5-minute break. You guys can chat away and I'll look at what you're saying. Okay, here's where we're at. Doesn't look like much yet. It's an open cluster. It's in Gemini. Oh, we forget Auriga. God. All right, I'll do that quick. But anyway, let's take a peek. I'm going to go down here. I'm going to bring up the dark end to where some of it's clipped. I'm going to bring the bright areas. Oh, yeah, look at this. I'm going to touch this up a little bit. Oh, that's good colors. Oh, I'm enjoying this. I'll show you why in a moment. Okay, bring it up. Look what you got. Now, that's pretty excellent. Maybe it's a little too much. All right, so this big thing is M35. Screenshot it. This little thing is so much further away. This is one of the better, M35 is one of the better open clusters. And information-wise, it's 5.1 magnitude, 40 minutes of arc, which means it's slightly bigger than the moon, which is 30. And the distance is 30 kilolight years. So it's 3,000 miles away. 3,000 miles. 3,000 light years away. It's got 500 stars, so it's really jam-packed. You can see the red stars. Remember, this is full scale. We're in it. And what about that faint one down there? So we're seeing a depth perception thing going on here. Wicked cool. So I'm going to read some of this stuff. Some of it. Oh, you guys are dying off on the chat. Good. This also is the arm. Yep. What, the bottom right, not prepared to debate. Oh, God, you guys good. You're winding down. You're starting to get serious. This cluster's 100 million years old. Remember the double cluster? One was 3, 1.5, and 1.5. A word about ages. Most clusters, by a billion years, 90% of all open clusters are gone. Most of them are gone in 10 million years. So this thing is 100 million years and it's being held together because there's a lot of stars doing it. We were probably born in one of these open clusters and dispersed. But this little guy, NGC 2392, is so much further away. It's like, I'm sorry, 2158. It's 16,500 light years away. What? So this is 3 kilolight years. This is 16,500. So, and the color, notice the yellow. Blue stars are young, yellow stars are old. So it's a much older star, a cluster. All right, take your pictures. All right, last one of Gemini. Yep, before we take a 5-minute break. Good, you guys are real good. M33, yep, Haley is definitely a local group. All right, did I get my cluster? Yeah, I got it. I'm gonna clear this. I'm gonna pause it. And then last one, We're going to look at the Eskimo Nebula, also known as the Clown Nebula. So let's go there. I'll type in Eskimo. I heard that a derogatory term. I heard people don't like the word Eskimo anymore. You know, I don't know. Okay, we're going to find it. Look where it is. Right near Pollux's business section. So there's where we're going. We'll slew there. Watch the scope at the bottom left-hand corner move. We got the best part of the night coming, the most beautiful stuff. We are still in the arm. In fact, everything else is, except for one more object, is arm. So put down arm in everything, but the last object is of the evening. Everything else is the arm, the spiral arm of our galaxy. Okay, you're recording that. I'm going to resume the capture. I'm going to get you guys a view. After this, we'll take a break. The Eskimo Nebula. Reminds me of that song. No, I better not sing it. Something about an Eskimo. It's really a good song, too. All right, what do we look? What is this? I don't know. What is this? All right, let's play with it. I'll bring in the dark end. All right, I will make sure that it likes the background color. I'll bring up not too far. What is that green spot? What the hey is that green spot? All right, word about the Eskimo Nebula. Magnitude 9.2. It's a planetary nebula. So it's small. It's like 40 seconds of arc. It's not even a full minute of arc. And a distance of 4.2 thousand light years. Let's get closer. Let's see if we can see the Eskimo. Wait a minute. I can see the Eskimo. Can you see the Eskimo? He's sideways. You got to look inside that green dot. Wait, is that too bright? I don't know. I can see a clown face. There's his smiley face. There's his nose. He's got the fuzz all around him. I don't know. Hard to see that. Let's see if I can bring the darks in a little bit. Yeah, I can see some details in there. So this is a star that blew up. Notice the color. Again, magnitude 9.2. Very small. 4.2 thousand light years away. The star coughed up 10% of its mass when it stopped burning probably hydrogen. And notice the green. The green deals with the chemicals that are out there, maybe a lot of carbon. Generally, that's what it is, diatomic carbon, that gives you the color. But not always. So I don't know for sure what this is. All right, what do we got? We got a break. Planetary nebula, yeah. All right, you guys screenshot this. Armageddon. Armageddon. All right, where are we at? We're at me. All right, you guys, stretch. We got the best stuff yet to come, but there's a lot more gas. One more planetary nebula. Some of the most amazing things in the sky when we get into Monoceros. All right, on the clock, it is 7:30. You've been at it for a full hour, some of you longer. Yeah, go to it. Break. I only see a white dot in a green dot. Yeah, Joe, good. Yep. Not 42 kilolight years, 4.2 kilolight years. There we go, August. All right, you guys. You're doing good. My favorite ice cream. God, I'm not really ever thinking about what my favorite ice cream is. What do I order? Pralines and cream, chocolate chip cookie dough. Those are my two go-to flavors. I go for the pistachio. I go for that too. So why were you asking? Did we lose that guy? Jimbo was timed out for 300 seconds. Thank you, Clark. You're doing good. Could you show me where this is in the map again? Yeah, we go back to the map. It's still there. Guys, you can see it on the map. But I'll get closer. There it is. So Eskimo. We forgot Ariga. 1, 2, 3, 4, 5, 6 more objects. Yeah. You know what? Oh, yeah. Again, we're on a break for another 3 minutes. We'll get back in a second. You guys are getting your beverage. If you want to see the sharp cap again, there it is. That's the Eskimo. That's full magnification. Remember, this is what all the other objects you see. You see a nice little thing there going on. Looks like a galaxy. Hard to see that. Kind of pretty. All right. But that's definitely a green monster. If I bring it up brighter, it just blows the whole thing out. I can see a funny looking face in there. Planetary nebulas are some of the most oddball, beautiful shapes. There's an interaction, a play between other stars. Most stars are multiple star systems. So you got that going on. Sometimes I have a theory that maybe if there's a lot of gas giants, you're going to have some captures. The rotational speed of the star itself will have a play. You have helixes. We did see the Saturn Nebula and the Helix Nebula in the fall. And remember, those planetary nebulas were pretty odd in shape too. So there's that. Let's take a peek real quick at the telescope, see what it's doing. Yep, it's pointed over in Gemini. That scope is at the limits of what is being held. It's on a 10 micron mount. It's the one that fell over. The other side of this tube is slightly dented, but it's working fine. Yeah. All right, 2 more minutes or less, and then we'll get going. Let me go to the next area so you can, some people want it who are waiting, just wait. Well, what time do we continue? 7:35. How long is the break? 5 minutes. We're not going anywhere. You're in your house, unless you're not. All right, I'm going to bring us and get us ready for the next one. I'm going to go to the Cone Nebula or the Christmas Tree Nebula. Both cone. Oops. I don't know if it's going to do it. No, that didn't do it. Let's go NGC 2264. All right, let's see if we can find that. Maybe it was finding it. Yeah, it's going to find. We got some outstanding stuff coming up. I love this. This is going to be neat. Okay, bathroom break. Get it ready. 1 more minute. I failed to remind you guys, we are looking into the depths of space. We're looking right now, right outside your window. Only up to, so far, besides the galaxy, only, and that one little cluster, less than 10,000 light years. We're near this arm, sandwiched between 2 bigger arms. All right, it's 7:35. We're back to it. Okay. Scope is going to go down into a constellation you never have to learn. It's called Monoceros or Monoceros. I think it's Monoceros. We're going to go to the Cone Nebula and the Christmas Tree Nebula. They're both called the same thing. I put down Cone. It's a lot easier. It is a open cluster with nebula. So you could either put OC or emission nebula. All right, I'm going there. Slew away. Watch the scope move. And barely it's moving. We're not going that far. We're into the thick of the arm of the Milky Way. Let's go and start taking our images. Well, I'm probably going to get some messed up stuff here. Let's clear it. Let's pause it. Let's resume it. Let's clear it. 10-second exposures as we did before. 15 seconds exposure. First one coming in. We reset it. We're supposed to see a Christmas tree out of this. Okay, you can see the open cluster. I'm going to make the background neutral. We've only stacked 15 seconds worth. I'm going to bring up the dark end of the spectrum. Notice I never touched the high ends. All right, I bring that up. I don't see anything. 30 seconds is there. Let's do one more of those. Nothing. Okay, now I'm going to bring the middle. You know, you might wonder, Mr. Burrow, what are you doing? What are you doing with all that? Well, we're continuing. So this is the Cone Nebula. Objects that we see in the sky, if you think of a spectrum, left is black, white is right side of that spectrum you see on your DSLR and you wonder what's going on. And then you got your middles. Well, stars all the information is in the dark end. So I've got to drag and, here we go, let's do it, and compress and bring out and make the far end. Oh, here we go. You don't see it, do you? I do. All right, got to bring it, darken the background a little bit. Okay. Give you information in a moment. Oh, you can see. All right, we got emission nebula red. We got reflection nebula reflecting off of bright stars here. And then we got this red cloud. We need to let this sit for a while. All right, what is this? It is an open cluster, magnitude 3.9. I've tried seeing it before with my bare naked eyes because I know it's brighter than that, but I could see granulation, but with the binoculars, you could barely see it. Size of this, you could see 1 full moon goes here and 2 this way. We're going to get more of this. You can even see the dust in front. And 1,000 light years away. It is truly in the Orion arm. Let's get some more colors. Don't take your pictures yet. I'm trying to bring out the reds. Trying to get this stuff. Oh, a little too much. You're seeing it? Now I'll explain the cone in a moment and the Christmas tree in a moment, but I'm hoping I'm not, okay, a little bit yellow on this. Oh, heavens. Oh, heavens. You can now see it. Here's the cone part of the nebula. We have protostars being born in here. Stars being born. Yeah. The end of Monoceros, we'll get to it again. This is the cone nebula, and coming this way, looking sideways, is the Christmas tree, with this being on the star, known as the Christmas tree nebula. So, if you put open cluster, you're right, because this is where stars are being born. And remember, the reds are the emission nebula. I think this is a little yellow, so too much red and green in there. Let's see if I can neutralize it. Oh, I pushed the button, and what did it do? It turned it to green. Oh, and then I went too much red. Oh, come on. Better. Unbelievable. This thing doesn't have a touch, does it? Wish I could just type it in. I know, it's almost there. It doesn't give me, you might see what I'm doing. Bottom right slider is a red thing. I'm just trying to do it right, and it's not doing it right. What if I bring this down? Hold on. Okay, I'm going to try this again. Doesn't want to do it. I had it. Good. Okay, well, let's bring it down again. Now it's too green. Maybe that's why it's called the Christmas tree. Oh, jeez. I'm clipping all those colors. All right, what if I bring it down this way? Oh, no. Sorry, gang. It was so good before, but I lost it. I'm going to take it up a little bit of red. All right. That's okay. You taking your screenshots? I'm just playing with it. You can see all the gas and dust. It's beautiful, but we're not there yet. Damn it. All right, that's better. I'm going to take my image. Again, Cone Nebula. Let's see what you're asking for. Cone Nebula. Thanks, Paul. Yeah, we did the habit smacks. You what we doing? Swizz. Careful, Swizz. Stars and stuff. Can you go over the info? Yes, I'll do it one more time. For the cone, one more time. It could be called the Christmas tree nebula if you look at it sideways. Magnitude 3.9. Open cluster, or you can put down dark nebula. You can see a 3D effect. You see the clouds in front, and the distance is only 1,000 light years away, twice the distance of the Pleiades. I don't know. It's a little too green for me. Maybe I could touch the green down a little bit, but generally, yeah, one little tag. I wish this was a little bit more sensitive. I don't know. I can't get in between. Yeah, talk about giving you the strobe effect. All right, so there we go. I'll take one more last picture of that because it is kind of greenish, kind of cool. The Christmas tree is sideways. So we're in Monoceros. Next place we're going. It's waiting. Go on, give me 15 seconds. You know, by the way, that's a 5-minute exposure. It's going to get better. Okay, good. Pause, clear, pause. Okay, where are we going next? The Rosetta Nebula. If you want to see a good one and a good picture, here's where we want to go. By the way, there's where Monoceros is. It's kind of hard to find it on your thing, but it's there. Okay, I am going to type in Rosetta. R-O. Well, there it is, right? Rosetta Nebula. I'll find it. We're going into the head of the Monoceros, or the unicorn. It's called the unicorn. So draw that. This is another one of those. It is an emission nebula, but it also has the cluster going on. Yep, you guys are doing well. Guys, we're way, since I missed Auriga and the three open clusters, we're ahead of schedule. So that might be a good thing. All right, I'm slowing on over. And absolutely a crowd pleaser. This thing is amazing. Talk about a star birthing area with an open cluster underneath. That's where we're at. Let's go ahead and get you guys looking at it. There's the scope is not moved much. So we're over. Okay, we got to clear this. Got to clear this. So it did some weird stuff, but we're okay. We're okay. All right. I think you guys are looking in the right spot. Yep. Nothing yet. 15 seconds. Our first image will pop up. What do we want to know about this? Rosetta. R-O-S-E-T-T-E. You're better than I am. I can't spell. Magnitude. Oh, it didn't catch any. Magnitude 4.8. I have tried and tried with binoculars to see it one night. I swear I saw it. All right, right now it doesn't look like anything, but this is amazing. Wait till you see it. Again, Rosetta C50, if you want to do that. It's an open cluster and emission nebula. It is 5 times the full moon. 5 times. 4.8 magnitude and 5.4 kilolight years. All right. Mission nebula. Hydrogen area. 130 light years diameter. There's a central hole. Let's bring it out. We've only stacked 3. Let's see what we can get. Okay. We're hoping for it. Bringing it up. Okay, now I got to brighten up the midtones. And it's happening. Oh my gosh, it's happening. Oh, that is already sweet. Okay, look at this. 5 full moons in diameter. This star group has blown with its solar winds, cleared out this hole. Look at this. See if we can get some more colors in a moment. Just has to. We've only stacked 75 seconds. Only 75 seconds and we get this. Oh, it will get better and brighter. Don't take a picture of that yet. I want to get one of these. Colors look more natural. I like it. Still bringing out. I don't know if you see it. Lydia, thanks. That one looks dope. Joe, you get a point. Joe, that one looks dope. I like it. Remember, you get points. And I'm going to bring out some. Remember, this isn't the full flavor. Check this out. If I go 100%, look at the dust dancing in front of the dust in the back. The emission nebula, excited hydrogen. Look at the star cluster clearing out the middle. Let's go back. Okay, I'm gonna try and bring out some more colors without going fancy. I won't ruin it for you, I promise. I promise. I'm not going to touch anything else but mess with these. Ooh. We're getting some details. See some details coming out here? This is live, guys. You're seeing this image and these stars. This is 5,400 years ago. It left this area. These stars were born here. There's 10,000 star masses in this nebula. I'm going to make it better. Keep it going. Oh, I'm not crazy about the greens, but I'm not going to do anything about that. Oh my Lord, that is just beautiful. This is a Valentine's picture. Oh, it's even coming out better. A little bit green. I'm not going to touch with the I'm speechless. It's gorgeous. Okay, I'm going to touch it. I'm not going to touch the colors. Oh, you guys. Yeah. August, point. Swizz, whoever you are. Ah, damn gives you a point. Is this in the arm? Everything's in the arm until there's nothing else out of the arm. Yep. Look at this. I'm going to bring it up. Those details are amazing. Oh, geez, that's gorgeous. Look at the dancing dust. The emission. We have oxygen in here being burned. We got hydrogen in here being excited. I say burned, I meant excited. This is just dancing. I'm going to take my picture here. This is hard to believe that we can see anything like this. I know it's a little green. You remember, why is it green? There's a little bit of scatter light off the snow outside. Clarkatron, point. Yeah, coolest one yet. All right. We haven't seen anything yet. But that, by the way, is 4 minutes of stacking up the exposures. I'm going to take one more picture. I just love that. I can't believe it. All right. I'm going to clear. Clear. All right. I cleared. I'm pausing. Okay, good. Resetting. Where are we going to next? I told you it's going to get better. I'm going to go into Orion. There is so much neat stuff in Orion, and I don't want to lose our chance. So let's go. I'm going to type in M78. And this is a reflection nebula. The other one was an emission nebula with other stuff in it, an open cluster. But this is M78, and you're going to see some dark nebula. In fact, dark nebula, emission nebula. Let's find it. Okay, right here. There's so much cool stuff in Orion. All right, mark it down. What are we doing? M78. Remember, we'll do a total review. Well, I don't know how we're going to do a total review. I can just rattle off numbers. I can't show you the picture, but I can give you the numbers again. All right. Oh, are you not seeing? Did I forget to send you? Yep, there we go. Sorry about that, folks. Jimbo, cuss word. Get rid of Jimbo Milla. Get rid of him, Clark. He used a cuss word that's unacceptable. Yeah, we can see the map now. I know, I was a little bit behind. All right. Slewing. I apologize for that delay. Slewing on over past the Rosetta Nebula. I know, you guys. I know. We got it now. We got it. We got it. We got it. All right. We got it. Just go ahead and record it. We'll get you guys going in a moment. Okay. Let's go to the screen and start capturing our stuff. Again, I'm not the best at this. Okay. We'll go to Sharp Cap. We're going to see something that won't look like much, but I'll give you some information in a moment. All right, let's go ahead. I am where I'm supposed to be. I'm neutralizing the background. I'm going to give you some numbers. M78, this is a reflection nebula, meaning the stars are reflecting off of a cloud, but you'll see a lot of darkness there too. Magnitude 8.3, nothing to see yet. We're stacking it. I'm purposely doing it this way. Size between 6 and 8 minutes. The size of that supernova remnant, the Crab Nebula. Can you believe you saw that? 1054, the Chinese did. And the distance of M78 is 1,600 light years, smack in these Orion spur. Okay, check it out. Let me go ahead and bring up the darks. I know, we're all in the arm, all these nebula and such. Okay, there, and let's go ahead. I'm going to have to play with this. Okay, not much. Reflection nebula. Let's try this again. Okay. Let's go some more. I don't want to touch the color too much more. Nothing to see yet. And a little too red. Okay, a little too purple. All right, what do we got? We can't see the map? Can't see it? Am I stuck again? No, we're there. That was old. Whoa, 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 whoa. You guys are fine. You're seeing a nebula that's popping up slowly but surely as we're stacking it. It's a little purple, but purple's good. All right, we're still playing with this. All right, what am I doing? I'm still playing with it. I think it's got a little too much purple in it. Too much green. Oh, all right, I just destroyed the colors again. Oh, that's about right. Okay, here we go. I'll look at you guys in a moment. Right now, I'm trying to bring out the details. M78. Remember, 8.3 magnitude, 1,600 light years away. All right. I agree. There's a lot of reds in there. Reflection Nebula, RN. Holy cow. Come on, the green. Wish there was a more sensitive way I could do this. I'm still playing with the colors, guys. I'll talk to you guys about it. Okay, we'll leave it at that. Oh, there it is. That's a good color. Okay, what do we got? Do you see it? Oh, this is, my eyes are going squirrely. Oh, there's the dark nebula. All right, so very cool. Amelia, point looks like a broken quasar. No, but no, look at this. This star or stars are underneath the cloud's swirling everywhere, and it's only glowing because the stars are reflecting off the back part of them. It's like 3D. Joe, censorship. Yeah, we have censorship. We got people out of control. So here's 3 minutes, 30 seconds, M78, real small. What can I say? I could say cool. Now, one of my favorites. Oh, take your pictures. Arm. I better take my picture. M78, that's just crazy. You know what? I'm going to make this thing even nastier just because I can. Hold on, wait, there we go. Oh, okay, that's way too nasty. Yeah, that's pretty cool. 1,600 light years, yeah? Oh, look at it. I'm going to take another picture. One more picture for me. All right. So you guys are screenshotting, but that's wicked cool. Let's go back to where it was so you can remember that. There's where we are. You know where we're going? We're going to Alnitak next. We'll cover two at once. All right, I'm going to clear this, pause this. Okay. We're going to Alnitak. Here we go. On the road to Alnitak. I'm going to click right here, Alnitak. I'm going to slew on over. I want to get it before we get, and this is a highlight. Most people have never seen this. All right, what are we looking at? We're going to look at two things. We're going to look at the Flame Nebula and the Horsehead Nebula. All right. I'm going to get things going here for us. Flame Nebula and Horsehead Nebula. Let me get you guys over. So the scope is now pouring a little bit lower. All right. There's Alnitak right there. Alnitak, Alnilam Mintaka. And this is crazy. All right, let's go ahead and do some numbers. First of all, bring that up. Bring the darks up. Oh, I should be talking to you guys. Thank you, guys. I see now. The light is the eyes. Oh, that's awesome. There's a face. Yeah, aliens. Okay, the black's up. Oh, I'm going to bring up them down and brighten up the mids. And everything's upside down. Are you seeing it? The Flame Nebula is on top of Alnitak, and the Horsehead Nebula is bottom. I got to go over all the information, but let's let it. That's only 60 seconds. I need to stack, a good few minutes of this. So it's coming out. The pictures are loading up. The camera is much more sensitive than the eyes, and we can save this stuff. Okay. Clark, thank you. You're doing great. Not Big Brother's watching. Jim, yeah, good. All right. So here we go. What are we talking about? The Flame Nebula is an emission nebula, 10th magnitude, 820 light years away, less than 1,000. Here it is. Now we're going to get some better colors in it. Don't take the picture yet. I'm just letting it store up. So it is an emission nebula, but the Horsehead Nebula is a dark nebula, a DN. This is an EN. And here's a reflection nebula. We'll get closer in a moment. All right. And the Horsehead Nebula is also, it doesn't have a magnitude. It's dark. So no magnitude. And it's 1,600 light years away. So this one is closer halfway. You can see the 3D-ness. Let's bring out some colors. Oh. Oh, look at Alnitak getting brighter. Again, the colors aren't rendishing. I don't have that. Oh, baby. Oh, now that is wicked. Check this out. I know it's upside down. Let's go 75%. There's that dust sticking up, and all the graininess will go away as we stack more. Okay, again, Flame Nebula is this one right above Alnitak, and right below it is the Horsehead Nebula. All right, 10th magnitude, no magnitude. 820 light years, 1,600 light years. Look at the details. I'll get a little closer. That's amazing. I have seen it once in a telescope. Red Rock Canyon, Astronomy Club in the 2000s. Couldn't believe my eyes. Big reflector. I can actually see it. This is a reflection nebula. The stars. This is an emission nebula. Let's go back to regular. Oh, beautiful. All right, I'm taking a picture. How about you? Interesting. 10th magnitude, how far? I think we got that. I repeated it. What are the colors? Well, the colors, this is kind of a golden peach. Well, this is red, and this is black. Wow, looks like the very white girl's room with the space lights. Wow, looks like every white girl's room with space lights. Joe, you're on warning. Where are the numbers for the flame number? The Flame Nebula, 10th magnitude, 820 light years. 820 light years, 16,000 light years, no magnitude. Let's get some more out of the colors. Let's do it. I'm gonna really shock us. All right, that's it. I'm taking another picture. That is amazing to see this. You know what? Hey, at least you've seen it once in your life. That's how planets are made of. That's how stars are made out of. And this whole area is a big complex. So, okay, we're going to the best of the best next. Okay, here we go. You're going to clear this and pause. Here we go. Best of the best. And you guys, it's 8 o'clock. We have less than 15 minutes. Sorry about that. We're going to call it quits at 8:15. I want to get to just the best of the best and maybe some weird stuff. Jimbo 3, she was gay, I think. Was 8th grade history teacher. I think we don't need to talk about that stuff. All right, good. Thank you. Deleted message, deleted message, deleted message. Thank you, Clark. Clark, you're getting 5 points for this. Every time we do this, you're getting 5 points. Okay, where am I going? I'm going to M42. M42 and M43. M42. The Great Orion Nebula. Find it. Yep, in the dagger of Orion. Slewing. M42, M43. Slewing. We're getting close to the meridian. All right, this is good. What are we talking about? More nebula, emission, all sorts of stuff. All right, let's take a picture. Sharp cap. We're going there again. Right now, there's nothing. Okay, resume. Clear. All right, we got to let it add up. You've seen this with your naked eye and binoculars. It's amazing. And telescopes, and amazing. Trent, thank you. Spending Saturday night making fake books. Okay. This is unstretched. I haven't done anything to this. This is just plain what it is. And when I say stretched, remember, this is what you take with your camera. Then what I do is I make sure the blacks are black. And then I start bringing the beauty out. And this is only 30 seconds total. This will get better. Oh, geosynchronous satellites. Geostationary satellites. All right, it's coming. We're still getting better looking. The running man's over here. M42, M43. Here's the numbers you need. Magnitude 4.0, arguably the greatest and closest of all the well-studied nebula in the sky, birthing stars. Let's get it better than this. Darks are getting darker. Oh, it's getting pretty. Bringing out some lights. You guys, get off of it. Get back to this. Look how beautiful this is. You can't say this isn't absolutely gorgeous. What else do we need to know? M43 is next to it, 9.0 in 1,800 light years. This is 1,400 light years. This is 1,800 light years, so it's further away. Both are emission nebula, although you can see the dark nebula dancing in front. Oh, gosh, guys. Here's the Running Man Nebula. All right, we're not done yet. We are not done. We got to bring out some more. All right, I gave those to you. All right, the middle of this, I'm going to dim it out a little bit. Maybe you can see it. Our 4 stars. Let's take a peek. I'm going to go back again. I know we haven't taken pictures. Maybe they're too bright. In the middle is 4 stars called the trapezium. It's responsible for causing all the glowing for the most part. Let's get closer. Do you see the 4 stars? It doesn't look like 4 stars. They're blowing out the sensor. Okay, so I can't control that. But the trapeze are really causing it all to glow. Big star forming area. The whole thing is 10 degrees, and it's a part of a bigger complex out there. All right, wait, it's going to get better. Let's do it. Let's make it as good as I can. First of all, let's see if we can see all this stuff everywhere. Look at those geostationary satellites. M43's information again, 9.0. It is an emission nebula like M42. Distance is 1,800 light years. Remember that the M42, the big part, M42 is 1,400 light years. They're basically the same distance. All right, I'm bringing out colors. This is insane. You can see them. They're just everywhere. Hold on. Yeah, maybe overdone it. Oh, yeah, it's hard not to. As the Earth, as the Earth turns, the satellite stays still. But remember, the telescope is following the stars across the sky, so it makes it look like these stationary satellites are there. Oh, that's gorgeous. A little green, don't you think? Oh, yeah. I think I clipped the blacks. Oh, that's gorgeous. That doesn't even make sense. All right. It depends on what you like. You like more colors? Look at that. Insanity. Some of the most beautiful stuff in the entire sky. Location is still in the arm. Yes. Amelia, another point. They are under the belt in the dagger. August, absolutely amazing. You get another point for that. When are we going to be done? Harry, you should be going. Can we keep going? 8:15 will be shutting down. I got like 2 more things to show you, so we'll get there. But look at this. I'm taking my picture. This is live out there. Look at the hydrogen gases. Stars are being coalesced into gravitational fields. This part, remember, is closer than this one. The Running Man, it's all a big part of a giant complex that's out there. The youngest stars are only 100,000 years old. 100, that's it. The trapezium, it is kicking out so much radiation of ultraviolet light, it's causing it to glow. There's 700 stars in that by itself. All right, 2 last to go to. Not as impressive, but here's not in our arm. All right, USC volleyball. We're going to pause. We're going to Lepus. Here we go. Down to the rabbit. M79, 2 left, you guys. Hang in there. Got to see something new. I don't know if we're going to be able to see it. It's going to be interesting. I'm going to type it in here. So wait, and then I'll go ahead and just so you guys can see it. M79. I'm going to slew it. Watch it move. The telescope's going to move across the world. Oops. If I do it right, menu. M79 is a globular cluster. In its scope, look at it move. Moving all the way around the world. I'll come over here and I'll type it in. And we'll find it. So you'll know where it is. Come on, find it. Ooh, it's going to be close. All the way around the world. How are we doing? M43 is a smaller one. Yep, absolutely. Can we look at M87? Mario, not until springtime. All right, there we are. M79. That's its location here. I'll make it a little bit easier. Below Lepus. There's so many more things that we could see, but we're near the end because I'm getting tired and you guys have seen a lot. We just got to do all our work for it. And we can't see M87 because it's over in Virgo / Comma Berenices. All right, what are we doing? Trying to take a picture. Sharp cap. Let's get it going. Resume our pictures. All right, what's the word? M79, 7.7 magnitude. Size, 10 minutes. Globular cluster, 42,000 light years away. Face of our galaxy. Oh yeah. Let's darken the blacks. Bring down the medium brights. There it is. We haven't seen one of these since fall. This is a weird one. We normally see these around the halo. Hello. But it appears that maybe this is an escaped galaxy from another galaxy that our Milky Way is eating up. Little green. I don't know why. Let's go ahead and see if we can fix that. A little bit less green. Yep, there it is. M79, 42,000 light years away. Not as far away as M33. Here we go, looking good. Take your pictures. I am. All right, one last thing to look at. Do you want that information again? Sure, 79. Magnitude 7.7, distance 42,000. Unusual location. It is probably escaped as the Milky Way devoured or is devouring the Canis Major dwarf. Yeah, the Milky Way has captured a bunch of little galaxies over time. That's probably a lot of the star birthing area. Look at that. You're like, okay, that's interesting. Yeah, that should be good. All right, last object. Where are we going? Well, there's tons of stuff out there. So I want to make sure you guys know that I am just touching it. I'm just barely getting across it. We've got stuff over here like, whoa. Like, we forgot to play. We got this. We have got, we got a variable nebula in here. We got M41. We got M48. We got M47. We've got M36, 138, 36, 37. We didn't even look at those. We got the Flame Nebula. We did the Flame Nebula, but we got the, what's the name? Something about fire. I don't remember. Somewhere around there. But the last one I want to do tonight is M46. And there's a reason for it. It's an open cluster. They're usually not as exciting. We're going over here. Around the world again. We're going over in between, below Monoceros, in the constellation of Puppis, open cluster. And you might ask, Mr. Berlin, why are we going to another open cluster when we could have gone all these brighter ones? Because there's some cool stuff out there. I want to show you what's going on here. All right, moving around the world telescope, doing its final leg, its bow down. Yes, you need an exit ticket, but nobody's going to get the exit ticket until I've shown you the last one. Yeah, exit ticket time. So everybody taking a peek. All right. Is it there yet? I'm checking. Getting close. That's where we're located. Make sure you mark it down. M46. Yes, you can always, Drew, you can always rewind the live stream. All right, here it is. Let's do it. Time for our show. Why would I show you this last? Resuming. Clear. First image. Doesn't look like much. Here's the information you need. 6th magnitude again. 20 minutes of arc. Almost the size of the full moon. 4.9 kilolight years. About 150 stars. Really rich. Check this out. Bringing in the darks. Make it darker. The back. The dark stuff has to be darker. The middle stuff, bringing out the light. Come on, you. I don't know if you're seeing it. What's going on here? Look at that beauty. What, am I not doing that again? I'm not on the right screen. You are right, guys. I'm wrong. But as soon as it pops up, thank you, guys. There it is, M46. Take your screen capture. I've not made the thing available yet. What are we looking at? You see it? I'll get closer. What's going on there? In that open cluster, not really associated with it, is another star that has died and blown up. That's a planetary nebula. Take your pictures. I am. All right. You guys. No, don't leave yet. We got to do this right. You got your pictures? You got all the information? All right, you guys. Next week, you don't need to be here. What are you going to do? We'll talk about that when we get back from ski break. What about that exit ticket? I need to make sure we got it. So, exit ticket. Edit the assignment. Assign. Due by 9:30. You got lots of time to do it. Have a great night, folks. We saw some amazing objects, screenshots, beauty. It's out there. And if for the rest of your life you never even look up there, at least you had this moment to actually feel something. You guys, you've been great. Clark, 5 points. Location of that last one was Puppis, but you can say arm again. Arm is what we're looking for. All right. I'm supposed to assign. I'm waiting for the assignment. When it pops up, you guys can take off now. Just do it. What color suspenders am I wearing? Uh-oh. Uh-oh. Yeah, that's what I'm saying. Uh-oh. Are they no suspenders at all? What's going on? Prove to me you were here to the end. All right. You guys, it's been good. I have a great rest of the week. It is assigned. Wait, last check. I'm going to click on it. I'm sure I have to do the same thing again, which is making sure everybody's available. Come on. I know. You're welcome, Abby. My pleasure. Here we go. Resume. I know. I'm fixing it. Okay. Now it's good. Alex, Jake, Chloe, Harry, Haley. Oh, we got you. Magnitude of that was 7 point. No. For the last one was 6.0. Sophia, thank you. Abby, absolutely. Josh, exit ticket is taking it. Check it out. Wouldn't want to do anything else with my night. Paul, 1 point for that. Thanks, Bartlett, Jake, Billy. You guys, Max, Paulo, doesn't work, it's working. Amelia, you're welcome. You got points. Abby, you got points. Loved it. Brett, Kai, you're welcome. Haley, Brett, I don't think, yeah, it's working. Mario, how many of these objects could we see through an amateur? This is an amateur telescope, fool. An 80 millimeter could catch every one of them. We need to talk. Cynthia, it's open. Natalie, you're welcome. Parker, it's open. Harrison, thank you. Cole, Swizz, Brett, have a great night. Clark, you big help. I really appreciate it. I couldn't have done it without you. Paul, better. Couldn't have done it without you on a Saturday night. Lydia, you're welcome. Brooks, Sid, Ken, you got some points. Yay, good night, guys. Maddie, oh, yeah, well, I'll be in class. Zadie, lots of fun. Kate, I love your last name. Ishi, you're very welcome. Christian, all right, Chief. Reese, Natalie Miskowski, yoo-hoo! Cynthia, it's all there. Sarah, Troy, Lily, Joe, you're welcome, you guys. Parker, Trent, John Cross, Max, Matthew, Brandon, you're here. Good. Maddie, have a great night. Thank you, you too. Kieran, always a pleasure. Haley, love having you. Trent, light to begin with, then dark. Ooh, deep. Natalie, you still here? Thank you. You have a great break too. I'll be taking pictures. Cameron, you're welcome. Anthony, woo, pictures. Cole, you're welcome. Katrina, you have a nice break too. Mario, go find M87. How many of these objects could you see through your telescope? All of them with a camera. All of them. Taylor, Paige, nice. Christian, when is ski week? In a week. Christian, 2 weeks. We come back. Swizz, what's the answer to the exit ticket? Look at what I'm wearing. Have a great break. Andrew, you're welcome. Max, I put light because I didn't realize you changed your suspenders. What a fool, Max. All right. Yeah, I'm taking off a point. You're here, though. Max, I got it. Max, Gordon, you're okay. I'll write it down. All right, what else? Parker, you sneaky dog. What? You make a mistake? Happy Saturday. Jacob, you too. Aiden, Nullberg, you're welcome. A. Thompson, have a good time till I see you again, because remembering how long it's going to be, it's much for me. I know, too much for me. James, you tricked us. No! I just made sure you were watching. Can I get the exit point ticket credit? Billy, you got it. Max, you got it. Yay, pictures. Billy, you're welcome. Billy, other Billy, please, you got it. Have a great break, Mr. Bartlett. Zane, you're welcome. Bye, Mario. Swizz. You, Mr. Bartlett. It's Tyler. Tyler! I showed up late. Does that mean you have to? No, you can come on Thursday if you don't want to come on Tuesday. At least part of the class. Come at the beginning. And then we'll go. I'll see how much time you owe me. All right. You guys, have a great night. We're ending the stream.